Yes, hello everyone. It's great to see all of you, and it's great to be on this stage, and it's awesome to join PyCon community. And today, me and my colleague Beatriz, we are going to talk about Django Ninja for API development. And since we both work within the energy market, we thought it might be a cool idea to try to bring this topic from the energy market perspective. So a little bit about us. My name is Anastasia, and I'm a backend developer at Helicon Technologies. I'm a self-taught developer. I don't have a technical background. I didn't go to any bootcamp, all self-taught. I am a co-organizer of PyLady Stockholm, and as I said, no technical background. I actually used to be a dance teacher, and dancing is a very big part of my life still. And apart from that, I really enjoy hiking and roller skating.
Hello, everyone. My name is Beatriz.
It's not on, I think.
No? Issues? Did you have to?
No, maybe if you put it closer.
Oh, okay, sorry. My name is Beatriz. I'm also a backend developer at Helicon, and I got a specialization in software engineering. And I'm also a co-organizer of PyLady Stockholm, and I like to take photos, work out, and running. So let's go. You can find us with this user in LinkedIn, and I use the same user for other social media if you want to find me.
Yes, so a little bit on our agenda. So first of all, we're gonna talk what is Django Ninja and why did we choose it as today's topic. We're gonna see at its challenges and motivations, see how Django Ninja uses type hints and Pydantic, see its automated documentations, performance, and in the end, Beatriz is gonna show us some code. So what is Django Ninja? It is an API framework that helps us to build APIs very fast and make it type safe. It's super new. It was released in 2020 by its Django core contributor Vitaly Kucherявый. And right now, the latest version is 1.30. And it is heavily inspired by, maybe you've heard about it, it's called Fast API, made by Sebastian Ramirez. And if you've been last year at PyCon, he was there. So I hope you didn't miss that. And you can take a look at the GitHub repo. And also Django Ninja has a YouTube channel, which you can subscribe. And at the channel, Vitaly is talking about the goals behind the creation of Django Ninja. And when he was creating it, he was thinking that it should be easy to learn, it should be really fast in writing code and understanding it. It must have automatic documentations, should be secure, and should have a very high performance. So why is Django Ninja? First of all, how many of you heard or used Django Ninja? Can you please raise your hand? Exactly. So Django Ninja is called Django for a reason. You don't really see it, but it makes things very fast and with precision. So we noticed, we both use Django Ninja in our projects, in our work, but we noticed that when we speak with other developers, not many people know about it, heard about it. So that's why we thought it would be cool to actually speak about it and spread some news. It seems to be perfect for us, for our work. It's super fast, it's very easy to understand, it integrates really good with Django, and it's super lightweight, but very powerful. Yes, and since we're talking about the energy company's perspective, we try to take a look at what might be the most typical challenges you have to face when you create an API for the energy company. And when we're gonna go through it, you might say this is a typical challenge for any company. You're probably gonna be right. But we still try to follow the energy company perspective, maybe because it has still some special challenges. And the first one is that energy companies usually heavily use highly complex data, very hierarchical data models involving energy usage, smart meters, contracts, and pricing structures. And the big challenge is mapping those complex data, hierarchical data, into APIs, but still keeping it performant. The second is accuracy of data. Because we often dealing with billing or consumption data. The third one is very specific for energy sector, dealing with real-time data streams, and dealing with those, meaning that we need support both sync and async operations, and it's very crucial to create an API that deal with real-time data efficiently. Other three challenges is providing performance at scale, meaning that sometimes you have to handle a very large number of requests, especially during peak energy usage times, because this can, of course, strain your API. Energy companies often work with different legacy systems and protocols, and making sure you integrate with those correctly. Sometimes you should integrate or replace those systems, and it might be a complex task. And last but not the least, of course, API energy sector often handle very sensitive customer data, and it's very crucial to ensure the privacy of this data and compliance with regulations and GDPR.
So how Django Ninja helps to deal with those challenges? So it uses some Django ORM to make it easier to work with a complex relationship between models and query structured data. It uses also Django authentication and authorization. And as we said, Django Ninja has a lightweight architecture and async support for better performance, but scaling effectively requires additional solutions. And it also uses Pydantic. So let's dive deeper into Pydantic. So Pydantic is a data validation and parse library that enforces data type and provides detailed error handling, providing clear messages. And also it uses Rust for main validation process, making very fast. Also, it uses generated JSON schema from each models, make it easier to create APIs and connect with other tools. And it converts data to the right format, like turning dates into string. And you can have custom validators and data types. And it is used by around 8,000 packages on PyPy, including Fast API, Hugging Face, SQL model, Tortoise ORM, and of course, Django Ninja. And how Pydantic uses Django Ninja uses Pydantic. So with automatic data validation, type safety with Python type hints, simplified serialization, and error handling.
Yes, let's talk a little bit API documentation, and nobody has time for that. So the best part, and I love talking about Swagger docs, but Django Ninja automatically generates Swagger or Open API standard documentation for every point you define. And Swagger are partially powered by the Pydantic models that you defined. And it provides a really nice interactive interface where you can actually view your endpoints and you can understand request and response data type and test your API directly from the browser. And the best part that there is absolutely no extra configuration needed from you because all docs, as said, generated automatically as soon as you define your routes and models. So let's take a look, a closer look at it. So here we can see our user interface and structure of the API we created for this presentation. And Swagger, or an Open API, lets us design and develop this documentation effortlessly. It's just there. And these specs allow describing the whole structure of our API. With this interface, we can see how actually API looks. And it really makes the talk between front-end, a back-end, or basically any communication with the company or users that are going to use that API easy and effortless. Here on this slide, we can see input parameters, headers, body data that you can actually put directly into Swagger. And then you can run your request and get your response instantly. And here on the bottom, you can also see what the actual response data format you're supposed to get when you get status code to 100 and how it looks like, so you know what's expected from you. Schemas. Schemas is actually a very important, I would say, essential part of understanding how the data flows in and out of our API. And those schemas, they might be reused across different endpoints and can be found under the schemas section. And we can also see schema details here, so we can understand, again, the expected format of the data. And nice feature that if you have nested schemas, Swagger will display them very nicely in hierarchically, which really helps if you deal with very complex data models. And also, since it's open API standard, it doesn't have to be Swagger, even though Swagger is a very popular tool. You can use any other tool like Redoc, Postman, or Insomnia, and you can customize the look of your documentation. Yes. So a little bit more about testing, because when developing API, it doesn't, or we should say shouldn't, end with just building an API. And testing plays a key role, ensuring that your API is secure and reliable. And we ask our Q&A colleague to give some feedback on testing and building APIs for energy companies. And this is exactly what he said. It's always important how we handle testing during building process and afterwards. We should make sure to write comprehensive unit tests at early stage and then cover newly built API with integration tests in accordance with each request and business needs. So a little bit more on his insight. We created a small diagram of what he said. And basically, we can divide QA challenges on two parts, with API building and API testing. And on the building sides, we often can have very unclear requirements due to varying interpretation across different teams, for example. And evolving this API without breaking the existing ones means carefully handling the versioning and providing backwards compatibility. And security, of course, is also very important. And on the testing side, integration complexity might be a big challenge because we need to connect with other systems. Each system can have unique formats and protocols. Important to remember about that real-world performance is another area for testing that might reveal bottlenecks or some latency issues with your API. Also important part of building an API for energy company is making sure to test authentication and authorization, so you provide right access to right users. Testing with mock data sometimes may just not capture a lot of nuances. So to capture all that, it is nice to use logging and monitoring. So how can we make all this better? We can make this all better with 4 things. First of all, comprehensive testing, meaning that we need to cover all unit, integration, performance, and security testing. Also, real-time monitoring for both API performance and for security breaches. You can use tools like Prometheus for that, for example. The third one is version control and backwards compatibility. It's nice to use proper versioning practices to ensure backwards compatibility and uninterrupted services for the existing clients. And last but not least, environmental parity, meaning that local staging and production environment should be as similar as possible. So we try to avoid the most of environmental differences. And there are, of course, trade-offs, as always, with testing when we use Django Ninja. And with Django Ninja, we have a lot of strong advantages, but also some trade-offs to consider. And on the plus side, we have that strong integration with Pydantic, which gives us types of models and help with validation. It also supports automatic versioning and leverages a lot of Django built-in security, which means less setup for us. It is super lightweight. It has async capabilities, which make it highly performant and allow us very seamless integration with, again, monitoring tools like Prometheus. But on the trade-off side, we are working with a much less mature ecosystem. Again, it was released in 2020. So things like documentation or community support aren't as extensive as it might be in some other more developed, older frameworks. And while Django Ninja has async capabilities, testing async endpoints might be very tricky, because Django has a very largely synchronous nature. And additionally, while very beneficial for us at least to use Pydantic, integration with it might add more complexity in certain cases where it's not needed. So, summarize it up, key limitations of Django Ninja that we could identify. First of all, the biggest one is smaller ecosystem in comparison with frameworks like Django REST framework. Django Ninja has less mature ecosystem, making it much harder to find answers and solutions to some problems, which also meaning fewer built-in features, which also meaning limited documentation, because if you have newer ecosystem, you have fewer resources available, and very often developers need to heavily investigate and research for some open issues, which is of course very time-consuming. And the last is mentioned before, async complexity, because while Django Ninja supports asynchronous views, managing async complexity might be tricky, especially on the testing stage, because Django itself and Django ORM, they don't fully implement asynchronous support.
In terms of performance, we can see through this image that Django Ninjas handle more requests per second compared to Flask or Django REST framework. So we add more workers. You can see each stays stable, and compared to Flask and Django REST framework, it's not performed so well. But compared to Fast API, of course, we can say Django Ninja is built on top of Django, so it inherits Django performance characteristics. It's generally not as fast as Fast API because it is made for a synchronous task, and Django is traditional synchronous. Whereas Fast API is known for its high performance, especially for in asynchronous scenarios. So let's see a bit of the code, but for not getting embarrassed ourselves, we brought some snapshots for the structure. So here we can see here each has the same structure that Django has. So we have like devices folder, API folder, and some files like schemas and view. We will focus on the files on API. So here we have the code, and this is how we can create a Django Ninja app. And here we can define our endpoints. And also we can have our request schema like this and our response schema here as well. And in schemas file, we can only import Django Ninja, and it uses model schema and schema here. And we can see we are not importing Pydantic because Django Ninja uses Pydantic under the hood. So for specific situations, you need to import Pydantic to manage and use for validation stuff from Pydantic. But it was what we want to bring here, and yeah.
Yes, and as we mentioned in the beginning, we are both co-organizers for PyLadies, so we would be really happy if you join us. You can follow us on Meetup, LinkedIn, or Instagram, and we already have a new event coming soon. It's going to be on November 25th at SUNET at 5:30, so please come and join us at the talk. Yes. Otherwise, that was all right.
Yes. Yeah.
Yes.
Yeah, that's.
So we have time for a couple of questions. Any questions? Yes.
Hi, thank you for a great talk. I was just wondering a bit about this connection to Fast API, because you mentioned kind of the inspiration, and I can see this in Pydantic use and Swagger, and also I think the code looks quite similar. When would you suggest to use this in contrast with Fast API?
I think it's a bit tricky because we know like Django Ninja is built on top of Django. I think depends how much is gonna be your problem. So we are not saying, okay, you need to use Django Ninja. I think if your API is like super light and you don't need many stuff, you can use Fast API. Otherwise, you can choose Django Ninja because it inherits, it benefits everything from Django, and we know Django has batteries included. So yeah, I think it depends on the pros and cons of what you need.
Mm-hmm. Yeah, I guess if you need connection with Django,
yes.
If you then use Django Ninja. If not, and you need something lightweight and fast, use Fast API.
Yes.
Perfect.
Any more questions?
Hi. Have you had any points at which you thought, was this the right choice, or should have we gone with some DRF? Have you?
Yeah, I think the project that we are working on, they decided to not follow with Django REST framework because we know how much Django REST framework can be complex sometimes. And for developer experience, Django Ninja, it helps a lot. So that's why we choose use Django Ninja.
It might also be hard to say because project is quite new.
Yes.
But so far we didn't have any disadvantages. It's fine, it's good.
Yep.
Any more questions? Nope. Then if you have anything that you want to discuss with the speakers, please feel free to do it during the coffee break. And then we can move on to the next speaker.
Thank you.
Thank you.